All right, good afternoon, and thank you very much for coming, especially that there's a snowstorm outside. I know for those who live in Boston, it's probably really hard to make it over here. On the other hand, for those who had flights early, those flights are probably canceled, and so that's why we have a little bit higher attendance because of that. So my name is Nikita Shamgunov. I'm the CTO and co-founder of Mem Sequel, and today we're going to talk about the fast path to building operational applications with Sparc. So before I get to the gist of the topic, let me talk a little bit about Mem Sequel and the story of why Mem Sequel even exists as a technology. Back in 2010, I was working on SQL Server, and the big dream over there at Microsoft was to deliver on in-memory and scale-out technology. So I would say now in 2017, SQL Server delivers on in-memory quite well with column stores and Project Hackathon. But scale-out was a very tough nut to crack. And I would say, fast forward 7 years, SQL Server still does not have a scale-out solution. And the reason to that is it's very hard to build a true scale-out product based on the traditional product that works very well in a single box. And a little bit of that is in the innovator's dilemma, and the other big part is the surface area is just so high, and feature by feature, you need to make sure that it works very well for scale out. So in 2010, I went to Facebook, and it was fascinating because everything is scale out. Every piece of technology is scale out. Should it be some storage systems? Should it be message processing systems? Should it be analytics? And back then, we were marching towards 1 billion monthly active users, and the sheer traffic that those users generate basically force you to build every piece of your technology in a scale-out fashion. And that's where, for the first time, I saw the power of in-memory and scale-out in action. We were analyzing a lot of events coming off of different servers, monitoring different metrics, monitoring the health of the system, and particularly enabling things like real-time code deployment. Right? If you're constantly shipping the new version of Facebook, you need to know very well and very accurately and very quickly if the code that you're pushing out is working. First and foremost, it does not have any performance regressions, and it does not bring the cost super high. That was about the time that Facebook introduced Ticker, which is this mini feed that goes on the right upper corner of the web page, and Ticker actually consumed more than 10% of overall cost for running Facebook. So even though there's like a little tiny window, but that's how expensive that was. So keeping the cost down was incredibly important, and it's a big data analytics problem. Every time you deploy a piece of code, you need to have very precise understanding of the performance of not only the website itself, but each individual function that runs the website. So fundamentally, we were making the business faster by providing data and data insights to every developer fingerprints. So the toughest nut to crack, and in Facebook or otherwise, was to scale the database. And the reason to that is that the databases have state, they're operational, they support transactions. But the dream was always, you want 2x performance or you want 2x storage, just add 2x the nodes. So that's how we started to work on Mem Sequel. In February 7th, 2011, I left Facebook, and we were hard at work building the Mem Sequel technology. So in my talk today, I will introduce you to Mem Sequel, what it is, why it matters, what it does really well. We'll talk about the Mem Sequel Sparc connector and the better together story. Because certain things you are much better off using a very fast, reliable system of record SQL engine. And for many cases, for doing some deep analytics, you want to pull that data out of Mem Sequel, bring it into Sparc, and potentially drop it back in. And then the bulk of my talk is actually about a particular use case that we see over and over again with our customers, is how to deliver on entity resolution at scale, in particularly around fraud detection use cases. There are a lot of libraries out there, and I'll be mentioning Duke as a library that lets you run entity resolution. But it is a very computationally expensive problem, and at scale, it just, you just won't have the lifetime to evaluate every possible pair of people and make sure if it's the same person or not. So we'll be talking how we'll be able to prune the search space and using Mem Sequel and Sparc together. All right, so what is Mem Sequel? Mem Sequel is a hybrid cloud data warehouse. It's scalable and elastic, right? It supports petabyte scale. It is high concurrency. You can run millions of operations per second against Mem Sequel. You can run very simple queries, such as, go and insert this row into Mem Sequel, or update this row into Mem Sequel. And many customers leverage the fact that we can update the state very quickly. But it also allows you to run complex analytical data warehousing queries. It is a system of record, operational, and real time. So what is real time? Real time means that you don't need to land data somewhere before you analyze it. In Mem Sequel, you can stream data into the system. You can either run inserts, or you can subscribe to streaming data sets such as Kafka or Kinesis. It's extremely compatible with the ecosystem. ETL tools, BI tools, things like Tableau and Looker, you can easily attach BI dashboards to Mem Sequel. And on the ecosystem side, it's also compatible with Kafka. You're able to just point at Kafka topic and say, well, stream all the data from that Kafka topic into Mem Sequel, and it will start populating data at a breakneck speeds. And it's also compatible with Sparc. And the way compatibility with Sparc works, you are able to create data frames on top of SQL commands you run against Mem Sequel. And this is an operation that is extremely fast because it enables cluster-to-cluster communication. There's no single bottleneck or network interface where all the data needs to go through. You're able to transfer data between Mem Sequel and Sparc one way or the other in a parallel fashion. And then on the deployment side, those are the checkboxes that we hit. You can consume Mem Sequel as a managed service. Basically, click a button, and Mem Sequel is for you there in the cloud. It also runs on premises, and a lot of our customers, particularly in the fintech sector, that for various regulations are not as much prevalent in the cloud, enjoy the fact that they can run Mem Sequel on premises, and that gives them a path to go into the cloud eventually. And Mem Sequel also supports a community edition. And the community edition is unlimited scale. You can run it on as many nodes as you want. But it's limited in terms of security features and high availability features. We've been hard at work since 2011. And just in 2016, Mem Sequel was named as the #1 operational data warehouse by Gartner, which is the #1 analyst firm for the enterprise software. Yeah, thanks for taking pictures. We're really proud of that fact that just happened. All right, so we live in the on-demand economy, right? So that's why giving people the ability to run real-time analytics is extremely important. Data is coming off of sensors, cell phones, you name it, and people want to run reports, people want to understand the pulse of the business, as well as they want to run predictive analytics. That is a very I would say this is a very profound change that has been happening for the past 5, 10 years, that you want to know how your business used to perform by looking at the historical data. Then there's been a push for real time. You want to know how your business performs now so you can adjust your actions and react to what your customers are doing. And ideally, there is no human on the path of that interaction. As you go on Amazon.com and you search for, I don't know, diapers, next time you go on Amazon.com, it's all the baby products are on the front page. So that decision, that analytical decision, is made in real time. And that's like the most advanced companies are already doing this and have been doing this for a few years. And finally, the predictive analytics is where your business is going. Looking at the trends, training your machine learning models, and then operationalizing those models into the front line of your business allows you to basically delight your customers and advance your competitive advantages. So let's understand Mem Sequel and Sparc. This is one of the classical examples of how people use Mem Sequel together with data incoming in Kafka, processing data in Sparc, and pushing this data into Mem Sequel. This is not necessarily just the ingest use case, but it's also a transformation use case. In the Sparc part, you're able to run predictive analytics. You're able to do things like IP to geolocation resolution. And then you push data into Mem Sequel, into hybrid cloud data warehouse. Now all the data is available to all your analysts, and now this data is available to serve reports or serve data to your customers. The difference between Mem Sequel and something like Redshift, you never put Redshift in front of the World Wide Web. You only give Redshift to your analysts, to a smaller subset of users who are running heavy analytical queries. With Mem Sequel, you can run analytics at web scale. So you can, for example, enable analytics to all your customers that are using your product in real time. So this is how you use Sparc and operational databases, and Mem Sequel is an operational database or operational data warehouse. In Sparc, the interface is mostly programmatic, right? So you write code. You write code in Java. You write code in Python. You use Juniper notebooks. With the databases, the interface is declarative. It's SQL. Right? You tell the database what you want. You write a SQL statement. You get the result back. The other dramatic difference is the execution environments. So with Sparc, there is a job scheduler, and everything you run against Sparc is a job, which means that achieving very high concurrency is hard or next to impossible. So if you want to run thousands, tens of thousands, hundreds of thousands, millions of operations per second, that wouldn't be possible in the system that puts job scheduler as the primary interface to sending workloads. With a database, and with Mem Sequel in particular, there's a SQL engine, and it's built for concurrency. And it has a cost-based query optimizer and a query, really fast concurrent query execution that runs over the state that is persisted in the database, right? In Sparc, you run your workloads against RDDs, data frames, data sets, and this data is yours, right? So you pull that data from, and it kind of encapsulated in the job that you're running. So you pull that data from an external data source, HDFS, Mem Sequel, Cassandra, file system, you name it. And it's not shareable across jobs, right? With Mem Sequel and other operational databases, the state is shared across all the connections. And then as you run queries, you compute results based on that. And finally, databases provide you persistent storage. With Sparc, you obviously need to latch on into an external storage. which makes a ton of sense for what Sparc is doing and makes a ton of sense for what databases are doing. So today we're proud to announce MemSQL Sparc 2.0 connector. There's been a number of changes, and everybody who's been in the Sparc ecosystem understands the differences between Sparc 1.5, 1.6, and Sparc 2.0. And it's been there's been a lot of demand for supporting MemSQL Sparc 2.0 connector from our customers. So today we're happy to announce that we have it. It's on GitHub, and it's extremely easy to consume. Like with Sparc 2.0, you just add another command to Sparc submit, and you reference MemSQL Sparc connector, and it's there. So that's fantastic. It downloads it automatically from Maven, and you're off to the races. Again, I just want to drive this point home. MemSQL Sparc connector allows you to transfer data between MemSQL and Sparc in parallel. And data that's stored in MemSQL tables can be moved very efficiently cluster to cluster. So you're not really bandwidth bound, right? Because on a 10 gigabit network, having 20 node cluster on the MemSQL side and 20 node cluster on the Sparc side, you can move a lot of data. You can move a lot of data in real time. Because 10 gigabits a second, you multiply by 20, and that is your bandwidth for transferring data between the two systems. So what are the use cases? The number one use case that we see over and over again, and we'll go over a few examples here, is operationalized models built in Sparc. So you train a model, and the model is, evaluating the model is a relatively inexpensive from the CPU standpoint operation, but that's what you want to put at scale. And that's what Amazon does when you search for diapers, and next time around you go and then they just evaluate a simple machine learning model that categorizes you as somebody who has a baby, and off you go, like you have all this products on your front page. Stream and event processing. So Sparc streaming is one of the most popular components in Sparc. And there's a good reason to that. It's a very easy interface to something like Kafka. And then in real time, you can grab micro batches off of Kafka. You can apply transformations to those micro batches and enhance and enrich that data. And then once that's done, you want to push this data into an operational data store, so eventually you can serve it to your customers. The third use case is something that I'll be demonstrating today with my fraud detection example. It is extending MemSQL analytics. So SQL, and by the way, how many people in this room know SQL? Yeah, everyone. So, so SQL is extremely powerful, but it's also rigid. And the power of SQL kind of goes hand to hand with its rigidity. The reason it's powerful is because there's a very powerful query optimizer that understands the data and the data distribution that's stored in the database. So that the query optimizer can come up with the perfect, or at least not disastrous, query execution plans. But also SQL is rigid because it can only reason over data operations if the operations are not black box. It knows what a count is, it knows what an average is or a window function is, and because of that, databases can reason about the data transformations and come up with a very fast query execution plans and actually run them efficiently. But when it comes to custom analytics, computing, I was chatting yesterday with someone, and he was bringing up that the specific type of histograms that he was computing. And it was tricky to do it in SQL because SQL just doesn't support it. But now with Sparc, it's quite efficient, right? Some computations you do in the database, which is kind of raw number crunching machine, and then you pull the results of that out and do more fine-grained computations that are very custom to your application. And finally, live dashboards and automated reports, like I said earlier, Mem Sequel is extremely compatible with all the BI tools. And so you can make a lot of computations in Spark. And then if you want to operationalize it and push that data into a dashboard, and this dashboard is exposed to a large number of people that are able to not only consume the dashboard itself, but have the ability to drill down and slice and dice that data further, that's what you can achieve with Spark and Mem Sequel. So once again, this is what a typical pipeline looks like. Data goes into Spark. In parallel, it goes from Spark to Mem Sequel. And then from there, it's available for the enterprise consumption. This is the event processing example. Again, data may come to you in a variety of formats. It can come with you in JSON, in Avro, in some sort of custom formats such as NetFlow. And for those who are in hardware and networking, they just understand that there's a big universe of all possible data formats. And because Spark gives you a programmable API and the ability to bring libraries, so that's where you can parse and normalize and unify those formats before you put it into a relational data store. Here, how you can extend Mem Sequel analytics. So data, in this particular case, data can come directly into Mem Sequel cluster. And then you want to, Mem Sequel cluster runs on an operational data store. It gives you a system of record. And then with Spark, you want to pull data out and maybe push some of the computations into Mem Sequel and maybe some computations in Spark and give you some sort of interactive machine learning terminal or dashboard and whatnot on an application. In many cases, people don't want to stress your operational data store with additional workloads. It's a very typical thing. Like if there's a database that powers your system, you're extremely careful about adding additional workloads. And analytical workloads can be quite expensive. So that's why you should be pulling data out of not just Mem Sequel primary, but Mem Sequel replica. And because we support replication, it's quite easy. OK, so let's get to the gist of the talk. So here's how you use Spark and Mem Sequel together. There's a bunch of URLs here on the slide deck where you can read about additional documentation. But if you want to use a Mem Sequel connector in Spark, you just call Spark shell -- packages and reference Mem Sequel connector 2.11 for Spark. It is available on Maven. It will download for you automatically. All you have to do is to add this additional switch to the command. So I'm going to flip very quickly over Spark use cases and case studies, and those are available on the internet. Manage.com is an ad tech company. It reduces the freshness of data from hours to minutes. Goldman Sachs had a presentation at Kafka Summit in April 2016, delivering real-time analytics with Kafka, Spark, and Mem Sequel. And one of our financial customers, who I can't name right now, is doing entity resolution and scale. So let's drill into entity resolution. So here's the problem statement. Let's say you're of a very large financial institution, and employees of that financial institution, and there are thousands of them, have many opportunities to take advantage of insider knowledge, right? Give some sort of preferential treatment to their family members, or perform some sort of fraud under someone else's name. So in many cases, you want to understand if there is a proximity between a person on the inside and the person on the outside. Maybe it's the same person, or maybe it's a family member or a relative. So Mem Sequel can process a very large amount of data very quickly, And so let's see how we can take advantage of that processing. So let's look at the numbers. So let's say there's 100,000 people in the target group. Let's say those are financial institution employees. And then there's the population, which is all the customers of that financial institution, which is about 50 million people. You can use a library, and we'll be using Duke for a given pair. One is from the financial institution, and one from outside of the world. Duke can tell us if that's the same person or not, what is the level of proximity between the two people. But if you look at the cardinality of the problem, this is 5 trillion pairs that you need to examine. This is simply not computationally feasible. And so in this example, we'll run the join between the two data sets, the target group and the population. And we'll see if the last names are equal, and this will allow us to prune the search space. But the other thing that we can do with Mem Sequel, because it supports many indexes, we also use all sorts of filters. And one of the key, apparently, one of the key things is the physical proximity between the two people. So if two people live within 50 meters of each other, there's a higher probability of fraud. And obviously, the data scientists of that financial institution, they play with that data. They add different filters. They match by the last name. They match by location. They match by address. And that's what you can do efficiently with Mem Sequel and Sparc. So in my particular example, the cluster has 288 cores. So I'm going to show you this cluster right now. This is a Mem Sequel dashboard. And that's kind of like the visual of that cluster, right? Each box here is a machine, and we're visualizing cores. So as you can see, that green is a CPU utilization by core. The cores are kind of quiet, but they're slowly dancing a little bit. So then I'm going to show you a piece of code. Like this is what we actually running for entity resolution. This is a Sparc job, and the key part of that Sparc job is here. So we're running that select statement, and that intersects your target group and a general population, and it filters that on geography within distance. That's where you leverage the power of Mem Sequel, right? So Mem Sequel supports geospatial indexing, and because geospatial indexing is there, you're able to efficiently evaluate this query much faster than you would run a general purpose join. And then once you're there, everything else is basically Sparc's bread and butter, right? You solve that hard computational problem with Mem Sequel. Now you take the results, you push them into Sparc. This is I'm scrolling over the example over the last name. And then you apply the Duke library. And Duke allows you to run all sorts of comparators. You can run Soundex, you can run Levenstein. Once it's in the Sparc land, it's easy. Like the hard part is to prune down a very large data set of trillions of rows down to something on the order of tens to hundreds of millions. And so then you can do it in parallel. So I'm going to go here and I'm going to run this job. And then you can see how we're starting to consume CPU on the cluster. And step 1 is running that SQL query. And step 2, and in this particular case, Sparc is just co-located with Mem Sequel. And step 2 is to push this data into Sparc and perform the final computation. These are the stats on the cluster size. It's 8 machines. It runs on Amazon. We love cloud. We offer Mem Sequel as a service. 36 cores per machine and 60 gigabytes of RAM. So it's a relatively small cluster for the amount of computation and the business value that it delivers. So in conclusion, Mem Sequel gives you speed in covering a massive search space. It runs, in this particular case, it runs in memory on commodity hardware. The data sets itself are relatively small, but the product of the two data sets is large. And if you want to do it faster, just add cores, right? So it's scalable technology. Mem Sequel uses indexes, and it uses, in this particular case, a geospatial index. And it streams results in parallel to Sparc for Duke entity resolution. Duke uses Metaphone, SoundX, 11-style algorithms to compare first name, last names, emails. It's very flexible. I encourage you to actually look at Duke. Many of our customers use that in production with Mem Sequel. And that's what Mem Sequel does. So that concludes my presentation. I think we have a minute or two for questions. Yeah, it's a very good question. So obviously, it depends on the cluster size. But I will give you a few pointers, right? So one of our customers, Pinterest, streams 1 gigabyte of data a second into Mem Sequel. That runs on a 16-node cluster. Data is incoming in thrift. So for every message, we have to parse thrift and convert it to basically CSV, and then push that CSV data into Mem Sequel. 1 gigabyte a second is extremely, extremely fast. So it's 75 terabytes of data a day, roughly.
Hi. I just want to ask a couple questions about the architecture, make sure I understand. You're creating, in essence, replicated shards, and do you have like a master slave within the replication so that your write-ahead log goes on one of the nodes? Is that how it works?
Yeah, so this is a very database-centric question. The answer is yes. Within the cluster, data is split into chunks that we call partitions. And we replicate data, and there are master partitions and slave partitions. And we write write-ahead log both on disk and to the network to the slave partition. And as that slave acknowledges the write, we acknowledge the transaction. Does that answer your question?
Yeah, it gets acknowledged on the slave. That was going to be my follow-up.
I'm sorry, I can hear.
Yeah, you're acknowledging after it writes to the slave. That was my follow-up.
Yeah.
Thank you.
Cool.
All right, thank you.